So this is the quiet, please. This is the problem we're going to do. So I'm going to look at, I just made this up, but SAT growth in integrated math, let's say. So Kraft's average growth was 60 points, standard deviation, 40 kids he teaches. My average growth was 45, standard deviation, 60 kids. And so I want to know, like, do Kraft's SAT integrated math students grow differently than Davis integrated math students? I don't know, better or worse. We're just going to say differently. So that's what we're trying to figure out in this example. So we have two samples, right? Like Davis and Kraft. That's why it's different than last week when it was just like one sample. So this is a two sample t-test. It's t because we're dealing with means. We're going to define the two variables, just like we did. We've done this a couple times, like with confidence intervals. So I'm going to say U1 equals true. True population mean SAT growth correct. When U2 equals true population mean SAT growth this. So your null hypotheses can be written, null is HO. It can be written two ways. So I put it on the sheet here. There, let's zoom way in so you can see that. That's really large. We start off assuming they're the same. Davis's growth and Kraft's growth will be the exact same. That's what your HO is always going to be. There's two ways you can write it. So these are both saying the exact same thing, which confuses some people. Like if I had 8 equals 8, isn't it also true, like if I subtract 8 from this side, isn't it also true that like 8 minus 8 equals 0? Like those are the same idea, right? So if mu1 and mu2 are equal, then it's also true that when you subtract them, you get 0. And you can write these either way you want. The questions that get presented to you will show it like in different ways, so you gotta understand both. But when you're writing it, you get to pick. Like I think that one that you can still see is a lot easier for most people. But you gotta understand that they're both ways it can happen. And then your HA, so it just kind of looks like a lot, but it's not that bad. So really, it's this. My HA might be, I think, Kraft's scores were better. It might be, I think, Kraft's growth was worse. Or it might be, I think, that the two were just different. And then those are like the same things, just written different ways. You guys see how those are the same thing? Yeah. Written differently? Okay. What's up? Are you good? Alright, so my HO in this case, I'm going to do the mu1 equals mu2. So I start off assuming they're the same, that the kids in Davis's SAT class improved by the same amount as the kids in Kraft's SAT. My HA, like I got to pretend I don't have the data yet, and so I'm not sure who would grow more, so I'm just like, yeah, let's just see if they're different. So I'm going to say mu1 is not equal to mu2. I'm going to write these down below. You don't have to. I'm just kind of showing that this could be written two different ways. So it's like the top or the bottom. You do not need both. I'm going to put alpha up here before I forget. alpha is 0.05. Just to refresh, if alpha is 0.05, what confidence level does that relate to? 95%. Nice. 3 days without stats. Questions yet? Alright, the conditions are the same as they were before, it's just like for both samples. So I did not say anything about randomness. I'm going to say assume both samples are SRS, or assume both are random. Again, I didn't really say it, so I'm going to assume each sample independent and independent from each other. And that's like that n is less than 10% thing, but they really don't usually ask that when it's a 2 sample for whatever reason. What else we got? There's 2 more. It's like on the sheet. Population, standard deviation, unknown for both. You have to work the beach like right after this. Is that what you're addressing? And then why is the t-distribution okay for both of these? N is greater than or equal to 30 for both. We have a large sample for both. So N is greater than or equal to 30. If there wasn't a large enough sample, I would hopefully it would say population normal. Because if it didn't, then we'd have to look at like dot plots to make sure those look good. Good so far? Alright, and then test statistic equals statistic minus parameters in general formula over standard deviation of the statistic. So your test statistic is T. And then what you're trying to do is compare the difference between these to 0. So I want to say this is x bar 1 minus x bar 2. So like in this case, what's x bar 1 minus x bar 2? It's 15, right? 60 minus 45. What's mu, and then this will be mu 1 minus mu 2. So it's like, this is what we got, the difference in our sample. This is what we expected the difference to be. So what did we expect the difference to be? What did we expect to be true about mu1 minus mu2? To be 0. So if the difference between me and crop comes out to 0, and I said it was going to be 0, well, that makes sense, it's fine. If the difference comes out to be like really far away from 0, that's when I can be like, okay, wait a minute, something's weird. These are different. And then the standard deviation of that statistic is the standard deviation of the first one squared over the sample size of the first one. S1 squared over N1 plus S2 squared over N2. And then let's t-value. Your calculator will also give you a p-value. And then, just to show you what I did here, I'm not going to make you write, they don't seem to on these tests, from what I've seen, make you do this, like hardly ever, for these tests. So I wrote it there, so if it comes up on the con or something, you have it, you can look at it and be like, okay, here's how I find the p-value. I'm not going to make you put it on the big essay. So this is kind of like FYI only, and I don't really need to write it. For this one, do this. So we're here. Crap, I skipped this. What did I skip? I gotta put the numbers in. Dang it. Alright, we're scrolling down here. Sorry about that. Alright, let's fill in those numbers. What's x bar 1? 60. X bar 2 is 45. And then mu1 and mu2, I don't know what they are. I don't really care what they are. What do I know is true when I subtract them? It's 0. So I would just put like 0 minus 0 there. That's 0. And then S1 squared, what's that? 15. N1. 40. S2 squared. 10, or so S2 is 10 squared. And N2 is that gives this number. Sorry about that. So we got your calculators, and let's put them in and make sure we get the same stuff, and we can do the test and everything. Here comes the Russian people tomorrow. Just one. So go stat tests, and then it's number 4. 2 sample t-test. 2 sample t-test. We good? Can I keep going? Bud, you okay? You need coffee? You just shoot it in your head? Gotcha. It's like Peter. He doesn't even use coffee. Alright. Put them in. Basically, the way it's set up here, like the first 3 things there are boom, boom, boom. The next 3 things there are boom, boom, boom. It's not always set up like that, so make sure you look, but it is a decent amount of time, actually. So put all that in. Choose which one we want. Remember, you always want it to be the same as whatever you put in your HA. So we put not equals. With me? I think this one says pooled. It's never pooled. And then you can do calculate or draw. I like draw because like if you draw what it shows you, you're good. So I just like I think it's easiest just to draw it. I'll write that down basically. So that's what I get. So P is freaking 0. Like it's not even a question. It's a better teacher than me. So I get T equals 5.55. And P value isn't even like 0.001 or something. It's just flat out 0. So, did everybody get those? If you didn't get that, let me know, because I'm sure some calculators use. Oh, okay, yeah. So, let's move the decimal over 7 spots. if you did calculate, you got that like E-7 thing. But that means move the decimal over to the left 7 spots. So now you're at 0.000006 or whatever it is, which is basically
I can't remember.
And that was Texas. I did not expect that. But then I had like a wire right about it.
Oh yeah. I was shocked when I saw him.
Oh, you saw like his announcement.
Yeah. Yeah.
Am I else for God for it? Or any issues pop up? That's like
Depressing. Yeah, I just figured it'll take
you
forever.
want to clear that out?
I can't wait until Saturday because I'm gonna be at home.
Any other calculator issues?
So I have to get home on Friday and then pick up.
Okay. So then we can decide, right? Our p-value is less than 0. So what are we going to do with HO? I'm sorry, our p-value is less than alpha. So what are we going to do with HO? Reject. Good. So since p-value, you do have to draw it. There's nothing to draw. It's like, I'm just going to write t equals 5. Because usually you like shade that, but it's literally 0. But since the p-value is less than alpha, we reject HO. There is enough evidence to support HA. What's up? Do you have a question?
Well, I was just sense, but it doesn't.
I think yeah. Okay. So do we think that there's a difference between Davis growth and Kraft's growth? We do. This was my HO. I started off assuming they're equal, but I rejected that. I was like, no, wait a minute. I think this is actually right. So I do think there's a difference. Here's another question. This is a little harder. And it's from 3 days ago. So see if you remember. What type of error could you have made here? A type 1 or a type 2? There's only one error that's possible here. So this chart will help, I think. What type of error could I have made? I don't know if I made an error really until I could see all the data. What was my decision? Did I decide HO or HA? I decided HA, didn't I? Because I rejected HO. So I basically decided HA. So once I've decided HA, this is gone. There's only 2 possibilities. I either got it right, and I'm happy, smile, or what kind of error did I make? Type 1. So if you decide HA, you are potentially making a type 1 error, or you're right. If you fail to reject, then you're basically saying, I think HO is fine, and you're either right, Or you made a type 2 error. Does that make sense? How that would work? There's your question on that. Anything I can go through on that one? Seem okay?
Do we have to like write any of this stuff?
So no, that stuff you might need for the con, but you don't have to write it on this template or essay or whatever it is. So this is all the stuff. This is the cheat sheet for Okay, so I'm gonna give you one. Have you do it, come up and show me, it'll be a check mark just to make sure you're like doing it right. If you get it wrong, I'll say to fix it. Like, you guys know. I'm not trying to penalize you, I just wanna make sure you're doing it right. Let's say I think that males and females, I suspect males get paid more than females for the same job. That's my hypothesis. So I take some data. I find out the average male salary for whatever job, I don't know, I'm just making this up, but for whatever job is, let's do it in thousands, so let's say it's like 48,000, females 42,000, standard deviation's 5,000, females at 7,000, and 30 in this sample, 35 in this sample. That's an 8. And let's use alpha equals 0.01. So I believe that's enough to get you going on here. So work through it. If you got a question, please ask. Bring it up when you're done. Get your check mark.